In this video, we're going to be discussing inequalities. And because we have done well with multi-step equations, we will go all the way through and make sure we get two multi-step inequalities within this video. One thing to remember that when you are solving an inequality and you end up multiplying or dividing both sides of the inequality by a negative number, you must reverse that sign. And so they have it described here as any number less than zero, keeping in mind that, yes, that's the same thing as what we would call a negative number. So looking at these single step examples, remember, we treat it like it's an equation. We solve it very similarly. Like to get t by itself, I would divide by 3. Since I'm dividing by a positive 3, I can keep the sign the same. So I just divide by 3 on both sides, and you get t is less than 2. On this one, you would divide by negative 8. Therefore, I need to reverse the sign. We divide by negative 8 on both sides. You would get s, reverse the sign, and you get negative 1/2. On this one, we would be dividing by a 5 to get x by itself. Since that 5 is positive, I would keep it the same. And so we would get x is less than or equal to negative 2. And then on this one, the variable's on the other side, I'm going to get a by itself by dividing by a negative 2. And so I'm going to reverse that side. If we divide by negative 2 on both sides, we're going to get 2, flip the sign, and then a. But this is actually not the way I would like this inequality to be written. Instead of saying 2 is greater than a, or greater than or equal to a, we can rewrite that, making the same statement and just say a is less than or equal to 2. So that way my variable is on the left side as it is for all these other ones. So these are equivalent in what they're saying. If 2 is greater than or equal to a, that means a must be less than or equal to 2. So that's how we would prefer to write that inequality. But let's go back and talk about these symbols. You've seen them before. Sometimes we forget how to read them. As we read them left to right, this one is less than. This one is greater than. Then we have the less than with the bar underneath it, and that bar means or equal to. And then also the greater than symbol with the bar underneath it. And that also means greater than or equal to. Now, when we are talking about the solutions to such an inequality, I like to rephrase this. And sometimes when I read my variable, I'll read it as like any number. Any number. So I'm saying any number greater than 4. And we want to illustrate that on this number line here. So I would put 4 on my number line somewhere, probably in the center. And I would put a circle at the number 4. And I want to mark any number that's greater than 4. Those numbers would be like 5 and 6 and 5.3 and 4.9 and 4.1, but not actually 4, because 4 is not greater than 4. And that's what the circle indicates. The open circle indicates that 4 is not a solution here. And then on this one, you'll notice the variables on the right side. If 7 is less than or equal to x, we can rewrite that and say that x is greater than or equal to 7. And so once again, I'm going to put 7 on my number line. And I'm going to read this as I did up here. Any number greater than 7. So we start at 7. The numbers greater would be over here to the right, the 8, the 9, and so forth. And this time, we're looking for numbers that are also equal to 7, and that does include 7 itself. And so we fill that in to let our viewer know that 7 is a solution here because of the bar that is underneath. All right. Talking about some phrasings that you might see if it was a word problem or just phrases that we use in everyday life. At least and at most. The phrase at least describes the least possible number that can be used, and the phrase at most describes the greatest possible number that can be used. So if the phrase was x is at least 5, that means x would have to be greater than or equal to 5, meaning the bottom that it could be was 5. Couldn't be any lower than 5, but it can be greater than that or equal to that. And then the inequality for x is at most 5 would be x is less than or equal to 5, keeping it from going above 5. So let's apply it to these scenarios here. You must be at most or at least 18 years of age to vote in a national election. That would be at least. An elevator can safely carry at least or at most 15 people. That would be at most. It would be kind of weird if you had to have at least 15 people to go on the elevator. When water boils, you know the temperature is at most or at least 212 degrees. That is at least. It's got to be 212 or hotter. If all books cost $3 and Jane has $20, she can buy at least or at most 6 books. And the answer is at most. She wouldn't have enough money for any more than 6 books. Now we're writing an inequality for those scenarios. So your age needs to be what compared to 18? Your age needs to be greater than or equal to 18. The elevator, the number of people in the elevator needs to be what compared to 15? The answer to that would be less than or equal to. The water's temperature, if it's going to be boiling, needs to be what compared to 212? And that answer is it needs to be greater than or equal to 212. And then this one, the 3 represents the price per book. The B represents how many books she plans to buy. And the 20 represents how much money she has. So at $3 a book, that's the cost. And this is the amount of money that we have. And this is a really good lesson for everybody, but you always want the cost to be less than or equal to the amount of money that you have. That's a good little life lesson right there. Don't buy things with money you don't have if you can avoid it. So let's talk about equations and how we solve them. I hope that we're able to look at this and just recognize what are 2 steps to getting f by itself. The first would be to get rid of the 7, and that would be done by subtracting 7. And then we would get rid of the 5, and that would be done by dividing by 5. On the next one, we would try to get r by itself. The first step would be get rid of the negative 12. We would do that by adding 12. And then how would I get rid of the 6? I would divide by 6. Let's apply this to an inequality like the one up here. We're trying to get a by itself. So we first want to get rid of the negative 7. We do that by adding 7 to each side. And then I need to get rid of this negative 6, which is being multiplied. And so we would divide by negative 6 on each side and reverse the inequality. That's a good thing to remember here. So let's go ahead and do that. We're going to add 7 like we suggested to do first. We get negative 6a is less than or equal to 24. And then I'm going to take that inequality and I'm going to get a by itself by dividing by a negative 6. And because I said I'm dividing by a negative, I put these little stars here to indicate to me something special is going to happen. We're going to flip that inequality symbol around. So it's A, flip this, so now it says greater than or equal to, and then 24 divided by -6 is -4. And so this inequality can be solved with any number greater than or equal to -4. And we could draw a number line for that. We can do that real quickly. Let's put -4 here. This would be -3, -2. This would be -5, -6. And we'd put a circle at -4. We want to go greater than that. So that's these numbers. But we also want to include -4 because -4 is equal to -4. And so that would be the graph for that. Okay, we have a few two-step inequalities here. So I will go through all of these, but I will pause after we do two and then let you try those on your own. You can check to see if you're right. On this one, you would subtract 6 first. After subtracting, you would get -3p greater than. These work together. That's -15. Next step is to get the variable by itself. We would need to divide by a -3. And since I said negative, I know that I need to flip that sign around. And we would get p is less than 5. So I'm going to draw this down here. Put 5 here, 6, 7, 4, 3. Put a circle at 5. Any number less than 5. Okay, that's this. And we don't need to fill this in because it does not say that 5 would be a solution. So this would be the final answer there. On this one, we're getting n by itself. I'm first going to get rid of the 5. I would do that by subtracting. And we would get -1. It's less than or equal to. Cancel those out. -6n. Now we need to get n by itself. I would do that by dividing by that -6 that is being multiplied to n. So I divide by -6. Once again, I'm dividing by a negative. And so I'm going to make this calculation. I'm going to flip the sign, and I have n by itself. N is on the right side of the inequality, and I would prefer if we had it start with n. So we're going to rewrite this. If 6 is greater than n, then n is less than 6. Of course, make sure that we have the equal to bar as well. So any number less than 6 and 6 itself. So we're going to draw that. Put a circle at 6. Any number less than 6 would be like 5 and 4, and then 6 itself. Okay, you can go ahead and pause this video and give these two a try, and then when you unpause it, my work will show up and you can check to see if you are correct. All right, so these two problems actually did come out as fractions, and that is okay, but I did not expect that necessarily. You didn't have to flip an inequality because you didn't divide by negative. You divided by a +4 on this one. Yeah, you get -3/2. Just make sure that you understand where that is on the number line. That's -1.5, and so right in between -1 and -2, we fill it in and we go to the left because we want less than and the equal to. On the right one, you didn't have to flip because you divided by a +9, but at the end, we did rewrite the equality with the variable on the left side. And so it looks like we're flipping it, but we really aren't. We're saying the same exact thing. This one was -1/3. Make sure that you put that in the right spot. And this one also is filled in because we are saying that -1/3 is a solution. On these examples, we add one more piece to it, and that is we have some like terms. You'll notice that we have 2n and 5n. Well, we're going to do 1 because the 1 that's there. Plus, when I put those together, we get 7n. And after putting those together, this problem is no different than the ones from the previous page. Subtract 1, subtract 1. Now we're going to get the n by itself. This comes negative 21. To get the n by itself, I'm going to divide by 7. And we would get n is greater than negative 3. And then, of course, we need to graph it. So here's negative 3, here's negative 2, negative 1, negative 4, negative 5. We start at negative 3. Any number greater than negative 3. Okay, not negative 3. So we don't fill that in. Let's do this one, and then once again, I'll give you an opportunity to try these two on your own if you wish. We have the negative 8n and a negative 7n. We're going to combine those. So I'm going to start on the very left side and rewrite. We have 23 greater than. I'm going to put these together. Negative 8 and negative 7 go together to become negative 15n. And then we still have negative 7. So from here, the variable term is negative 15n. I'm going to get rid of this 7 by adding 7 to both sides. And we're going to get 30 is greater than negative 15n. To get that n by itself, I would divide by negative 15. And let's compute this. So we get negative 2. And I'm putting my stars here because I divided by a negative. Flip that sign, and it should say n. Now, once again, I don't have the inequality with the variable on the left side, so I'm going to read it this way first. I'm going to flip it around, not the sign itself, but the entire inequality. Negative 2 is less than n. Well, that means n is greater than negative 2. And so we put negative 2, negative 1, 0, negative 3, negative 4. Circle at negative 2, any number greater than negative 2, and that would be this way. We do not fill these in because negative 2 would not be a solution. Once again, you can go ahead and pause, try these on your own, and then unpause, and my work will be there, and you can see how you did. All right, you can take a look here. On the left side, we're combining like terms, getting us 6n. Then we divide by 6. But my variable's on the right side, so I rewrote it with it on the left side and then graphed it. Combine like terms. This time we had to subtract 3 before dividing by 9, and then we get x is greater than 2. Neither of the inequalities should have the bubble filled in because the number negative 2 or 2 are not solutions on each of those respectively. Let's take a look at a couple more. In this one, you might notice parentheses are introduced to the inequality, and therefore we're going to be doing a distribution. We're going to take that 7 and we're going to distribute, and that would give me 14v, and 7 times 3 is 21. I'm going to get the variable term by itself first, which is 14v, and then get the variable by itself. To get rid of the 21, we subtract 21. And we would get two negatives going together. So I'm adding those, but I'm keeping it negative. And we're going to get 112. And we still have 14v. Now we get v by itself. I like to rewrite this to show that step separately. We're going to divide by 14. A negative divided by a positive is negative. 112 divided by 14, I believe, is 8. I don't need to flip the sign, so I'm going to write it as it was. And then these 14s cancel out, leaving me with v. So we have -8 is greater than or equal to v, or in other words, v, v is less than or equal to -8. And that's the inequality I'm going to use to graph. So we have -8, we have -7, -6, -9, -10. We will put a circle at -8. We will go any number less than -8, because that's what this says. But then also, -8 itself is a solution because of the equal to bar that I see. I'm going to go ahead and give you a chance to try this one. It is a little bit more involved. Um, let's see how you do. We will go ahead and do this one together. It has a little bit more than the previous one. We do see distributions, so I'm going to leave the -6 where it is. But then we have a -5 that needs to be distributed to the parentheses. And so we would get -35k. Negative times a negative is a positive. 5 times 4 is 20. And that will end my distribution. And then we have -161 on the right side of the inequality symbol. On the left side of the inequality, we should see some like terms. We have a -6 and a positive 20. Those are two numbers, the way I describe it, they don't get along. They go against each other because one is positive and one is negative. The 20 is more powerful than 6 and is positive, so the answer will be positive. Then we subtract 20 and 6, you get 14. We still have -35k, and we still have the less than -161. So once again, I have my variable term, and I want that by itself. I'm going to get rid of the 14. We're going to subtract 14 because it's positive. And when I do that, I would get -35k is less than -175. Okay, and then we are going to get k by itself. And we will do that by dividing by -35. So knowing what to do here is not the issue. The issue is knowing this calculation. And I'm going to get k. Notice that I divided by a negative here. And we're going to flip that sign around. K is greater than. A negative divided by a negative is a positive, and I believe the answer here is going to be 5. K is greater than 5. So we're going to put 5, 6, 7, 4, 3. We're going to put a circle at 5 and say any number greater than 5. That would be this way. We do not fill it in because it does not have the equal to bar. Let's continue with even more inequalities with distribution and combining like terms. We do want to write it at the end, as we have been, with the variable on the left-hand side. So starting this one out, we would distribute the 2. That would give you 2k plus 8. You still have the -3k and the less than or equal to 14. Still look at the left side. You have like terms, 2k and -3k. We have a positive 2 and a -3. Once again, they don't go together. They work against each other because one's positive and one's negative. The negative wins out this time because 3 is more than 2. 3 is only 1 more than 2, so it's a -1k. And sometimes that helps, that description. Plus 8, because that's still there, and then less than or equal to 14. To get the variable term by itself, I would need to get rid of the 8. Now we're going to have it say -1k is less than or equal to, and this comes out to be 6. I'm going to come up here and rewrite that and continue my work there. To get k entirely by itself, I'm going to divide by a negative 1. And once again, because I said divide by a negative, we will need to flip that sign. So we get k, flip the sign, and then 6 divided by negative 1 is negative 6. This one doesn't have the graph on there, so I'm going to go ahead and bypass that. Let's continue on this one. We'll distribute the 3, 12c, and then 3 times a negative 5 is minus 15. And then we still have negative 2c and greater than 0. Once again, on the left side, I have like terms with my variables. We have 12c minus 2c. That's 10c. We still have the minus 15. We still have the greater than. We still have the 0. Getting the variable term by itself, I would have to get rid of the other term, the constant, and we add 15 on both sides to do that. That will leave me with 10c is greater than 15. And I want to get c by itself, so I'm going to have to divide by 10 to get rid of that multiplication. And don't panic, but we will end up with a fraction here. We're going to get c is greater than, and now 15 over 10 is the answer, but we can reduce that fraction because I recognize that there is a number that goes into both of these, and that number is 5. The largest number that goes into both is 5. 5 goes into 15 3 times, 5 goes into 10 2 times, and so the answer is 3 halves. C is greater than 3 halves. Any number greater than 3 halves is considered a solution to this. Okay, continuing. This problem has variables on both sides, so it'll be a little bit different than this, but the same process as when we were solving equations with variables on both sides. So we will distribute the negative 2. That'll give us negative 2 and then negative 16n. And then the right side of the inequality will remain the same. So you have an option. We have variables on both sides. We need to eliminate one of those. It doesn't matter which. You may have a preference. I'm going to get rid of the negative 16n. I would do that by adding 16n. But of course, I have to do that to the other side of the inequality as well. And then we'll read it like a book, and we will get negative 2, nothing. This comes out to be 8 positive n, and then negative 34. To continue with this problem, I'm going to get my variable term by itself. I'm going to add 34 to both sides. And when I go to rewrite, I will have 32 is less than or equal to 8n. My last step, to get n by itself, I need to get rid of the 8. That 8 is multiplied to the variable n, so I'm going to divide by 8 on both sides. You'll get 4 is less than or equal to n. In other words, if 4 is less than n is greater than 4. Of course, making sure that it's still equal to. Okay, similar problem. Left side is actually already simplified. The right side does present me with an opportunity to distribute a negative 2. So we're going to get negative 8, and then negative 2 times positive 8 is negative 16, and we still have the x. We have variables on both sides. I'm going to eliminate one of them. I'm going to eliminate the negative 16x, by adding 16x to both sides. So 28, that will become positive 9x less than negative 8, and this will go away. Getting the variable term by itself, I'm going to subtract 28 to get rid of the 28. And that'll leave me with 9x is less than negative, these are working together, so we add them together, negative 36. And then one last step to get x by itself. Divide by 9, divide by 9. X is less than negative 4. Didn't need to rewrite that one because my variable was already on the left side. So it doesn't really get much more difficult than that. These are two problems that you could try on your own. I'll go ahead and pause this, and then when you unpause it, um, you'll have my work there. All right, so on this one, we didn't have to distribute or combine like terms, but I do need to eliminate the variable from one side. I decided to get rid of the 4n. This is what we have. Then it's a two-step. You add 16, divide by 3. My variable is on the right side, so I took the time to rewrite it with the variable on the left side. And we get n is greater than or equal to 6, and I graph that, filling in the circle, because 6 is a solution to that inequality. Same thing here, no distribution, no like terms. Eliminate the 5x is my choice here. I get 2x and a two-step inequality. Subtract the 9, divide by 2. My variable again was on the right side, and I rewrote it with it on the left side. Now it says x is greater than negative 5. Do not fill in because it does not say that x could be equal to negative 5. Here are two more of the same type. I'm actually going to skip those. And then lastly, what are the solutions to this type of inequality? And you'll see we would do it the way we did on the previous slide, but you would subtract 5n to get rid of 5n. And if I did that on the left side, I have to do that on the right side. And what happens is they actually will both cancel out. So it leaves me with a 9 and then is less than or equal to a negative 1. There's no variable in this, and so we need to just interpret this. 9 is less than negative 1. That is not true, and it never is true. And it doesn't matter what the variable would be because we have the same thing on both sides and they cancel out. So there's never going to be a solution to this. So just like with equations, if you wind up with a false statement, regardless of the variable here has no effect, then you're going to have a no solution. And if you wind up with a true statement, you're going to wind up with all real numbers being the solution. So in this next little piece is an interesting way to think about it. But look at this inequality. We've got a blank we've left here. We have negative 2y. Well, that will cancel with this negative 2y. The left side has one, the right side has one. It means it really doesn't do anything. So we are looking to make this say no solution, and we have a 6, and it says is less than. I'm going to pick something that 6 is not less than. 6 is less than 3. No, it isn't, and that's why it's going to be a no solution. Let's look at this one. We have negative 3x. We have negative 3x. Okay, those will cancel out. The left side and the right side have the same amount of x's, so they're not going to have any effect on the problem. It says something is greater than negative 4. I want this to be false because it asks me to do a no solution. And so I'm going to pick something that is not greater than negative 4, like even a negative 100 or negative 10 would work for that. So in the next set, though, we are asked to find an all real numbers situation. So we have 7j on the right side. Well, in order to cancel that out, I would have to have 7j on the left side. And I need to pick something that actually is greater than negative 11 here. And I can just pick 5. 5 would be a perfect answer there, among other numbers, of course. Here we have the 9p on both sides. Those are going to get canceled out. They have no effect on the problem. And we're looking to make it true. We have negative 3, and we want it to be greater than something. Negative 3 greater than, negative 3 is greater than negative 7. use red here, -7. And so this would be a true statement and therefore all real numbers. This one is true, all real numbers. This one is false, no solution. And this one is false, no solution. So that should give us a lot of practice with inequalities, and hopefully we have no trouble with that. If you do, though, reach out to me, let me know.